Hello. Motion curves. What are these motion curves? Simple. Equations of motion represented graphically. What does it mean? Let's check this example. A particle starts at origin with initial velocity 5 meters per second. That means at t equal to 0, x is 0. It starts at origin, means the initial position is 0 and initial velocity is 5 meters per second. It moves along a straight line with an uniform acceleration 3 meters per second squared. So it is uniform acceleration. Write equations of motion. So simple. This is standard motion, uniform acceleration motion. So in this case, uniform acceleration is 3 meters per second square. So this is first equation of motion, acceleration 3 meters per second square. What do you mean by equation of motion? So relation between these four variables, any two of these four variables, position, velocity, acceleration and time, that is equation of motion. So this is also equation of motion, in the sense this equation suggests you that acceleration is not a function of time t, it is not varying with time t. So this is one of the equations of motion. Then v is equal to v0 plus at or v is equal to u plus at. It is velocity time equation. And x is equal to v0 t plus half at squared plus initial position, that is 0 in this case. But what if I ask you to draw equations of motion? So along x-axis we take time in seconds, along y-axis we take one of these three variables, acceleration, velocity and position. So here I am taking variable as acceleration, and we show that acceleration is not varying with time but it remains constant. So this is that acceleration time relation we have drawn. And what does this line suggest you? That y coordinates are not changing. Y coordinate in the sense acceleration is not changing. So this is horizontal line. Now when we take time along x-axis and velocity along y-axis, it is VT graph, velocity time diagram. This equation is straight line. Y equal to mx plus c. Y equal to mx plus c. It's standard equation of straight line. So at t equal to 0, what is velocity? 5 meters per second. Initial velocity it is. At t equal to 1 second, velocity is 8 meters per second. At t equal to 2 seconds, velocity is 11 meters per second. And at any particular instant you want to know velocity, just put that instant value here and you will get corresponding velocity. So if you join all these points, you get this straight line. So this straight line is y equal to mx plus c or v is equal to u plus at. It is inclined line. Slope is constant. You know that if a curve is y is equal to fx, then dy by dx is its slope. Similarly, in this case, it is relation between velocity and time. It is Vt curve. So dv by dt is its slope, and dv by dt is nothing but acceleration we know. So when you use this motion curves approach, remember this statement, acceleration is slope of Vt diagram. It means when acceleration is constant, slope of Vt diagram is constant, and constant slope means inclined straight line. Along x-axis I have taken time, along y-axis I have taken position. At t equal to 3 seconds, position is 28.5. At t equal to 5 seconds, position is 62.5. Just I have chosen randomly some time instant values to get corresponding positions. So at t equal to 6, position is 84 meters, and of course at t equal to 0, position is 0. So if you join all these points, you get a curve and it is a parabola. Check this equation. Y is equal to ax squared plus bx plus c. This is standard equation of a parabola. So to draw equations of motion means to draw variation of those variables, acceleration, velocity, position, to draw variation in corresponding variables along time t. Now important thing is, when we know that we can solve uniform acceleration problems using these equations, acceleration constant v is equal to u plus at, x is equal to ut plus half at squared, then why we should study motion curves? This is important. Listen to me. In different time intervals, its motion is governed by different equations of motion. Then we should prefer motion curves approach to solve the problem. So to make you understand this, let's discuss this example. A particle starts at origin with no initial velocity, and in first 30 seconds its acceleration is say 0.25 t meters per second squared, where t is a time in seconds. It is one of the equations of motion where acceleration is varying time t. It is variable acceleration motion. But this particle moves according to this equation of motion for first 30 seconds only. Next 15 seconds. So from t equal to 30 to t equal to 45 seconds. Acceleration is 3 meters per second squared. Then next 50 seconds means from t equal to 45 seconds to t equal to 95 seconds. What happens in this interval? Acceleration is 0, in the sense particle moves with uniform velocity. And after t equal to 95 seconds, it reduces its speed uniformly to stop. That is, final velocity becomes 0. So from t equal to 95 seconds, speed reduces uniformly in the sense acceleration is constant but negative. It is opposite to velocity. It is retardation. It is deceleration. Let it be minus 3 meters per second squared. Now this is one example in which particle moves in such a way that in different time intervals equations of motion are different. So to analyze such a motion, we use a motion curve approach. Watch here, acceleration is 0.25 t meters per second squared. So first 30 seconds it is variable acceleration motion. T equal to 30 to t equal to 45 seconds, it is uniform acceleration motion. Next 50 seconds it is uniform velocity motion, acceleration is 0. And then from t equal to 95 seconds onwards, it is again uniform acceleration motion. In this lecture, we are just going to focus on uniform acceleration motion. Variable acceleration motion using motion curves we'll study in our next lecture. Take this acceleration as 2 meters per second squared. So we say that particle is moving along a straight path in such a way that its acceleration is different in different time intervals, but in each interval it is a constant. Let's draw AT diagram also. Variation in acceleration with time. So along x-axis we take time, along y-axis we take acceleration, and this information we draw in the diagram. So from t equal to 0 to t equal to 30, we show that acceleration is constant 2 meters per second squared by drawing a horizontal line. This horizontal line suggests you that acceleration is not varying in 30 seconds. Then next 15 seconds means from 30 to 45 seconds. 30 to 45 seconds, acceleration remains constant again, 3 meters per second squared. From 45 to 95 seconds, from t equal to 45 to t equal to 90 seconds, in this interval, acceleration remains 0. Acceleration remains 0. And from 95 seconds, acceleration is minus 3. So it is below x-axis or below time axis. Acceleration is minus 3. And this time instant, that is, it reduces its speed uniformly to stop. But at what time it stops? We are not sure about that. And that is why we have labeled it. This is also very important. Remember, we have drawn here AT diagram, uniform acceleration. Uniform acceleration means AT diagram horizontal line. So it's combination of horizontal lines only, acceleration time diagram. Now how to draw VT diagram? Acceleration is slope of VT diagram. Acceleration constant means slope of VT diagram constant. So that means in uniform acceleration motion, VT diagram again combination of straight lines only. Along x-axis time in seconds, along y-axis velocity in meters per second. And from t equal to 0 to t equal to 30, it is uniform acceleration, means velocity is increasing uniformly. So what is its velocity at t equal to 30? We don't know. So we should immediately label it, develop this habit. If you know the value, you insert in the graph. If you don't know, you label it. Okay. Now from t equal to 30 to t equal to 45, again acceleration is constant. From t equal to 30 to t equal to 45, acceleration is constant, means the slope of VT diagram is constant, or VT diagram is inclined straight line. But important thing is whether you have understood that acceleration is slope of VT diagram, and can you use that information to draw VT diagram. Now listen here, acceleration is 3 meters per second square, and in first time interval it is 2 meters per second square. So here in this interval, that means from 30 to 45 seconds, in this interval acceleration is greater than earlier interval. In the sense, in this interval slope of VT diagram is more than slope of VT diagram in earlier interval. So when you draw the line here, don't simply extend this line, show greater slope for this new line. So 30 to 45, this is VT diagram. So what is the new value of velocity reached? We don't know. So I have labeled it as V double dash. Now from t equal to 45 seconds onwards, acceleration is 0. Means 45 seconds onward, velocity remains constant. Acceleration 0 means velocity remains constant, or acceleration is slope of VT diagram. What does that mean? Velocity diagram is horizontal line. 45 seconds to 95 seconds, velocity diagram is horizontal line. And what happens after that? Speed reduces uniformly. Acceleration is negative, means it is negative slope for VT diagram. Negative slope means downward slope for VT diagram. And what is the time here? We don't know. So I have labeled it as t dash. This is a VT diagram. This is AT diagram. Now listen, how to draw AT, VT, XT curves, etc. in detail we'll study in our next lecture. What we are going to study in this lecture, listen. If a particle is moving in such a way that its acceleration is different in different time intervals, but in each interval it is a constant, then to analyze the motion, draw VT diagram. And what after drawing VT diagram? Area under VT diagram gives displacement, and of course displacement is change in position, and change in velocity divided by time duration is acceleration. Now listen, very important. If particle is moving in such a way that its acceleration is different in different time interval, but in each interval acceleration is uniform, then draw VT diagram and use these two equations. Which are those two equations? Area under VT diagram gives displacement, and change in velocity divided by time duration is acceleration. Now read this problem. A car starts with no initial velocity and accelerates uniformly along a straight path, and when its velocity reaches 108 km per hour, the driver applies the brakes so that car decelerates uniformly to a stop. If total duration of the motion is 21 seconds, find a distance travelled by the car. Okay, now I am going to draw VT diagram, and then after a few minutes you will get the final answer. But what you should understand this problem is, what is there in the problem that suggested you to draw VT diagram? A car starts with no initial velocity and accelerates uniformly along a straight path. So it is uniform acceleration problem. Then instead of using this formula V is equal to U plus AT, X is equal to UT plus half AT squared, I'm going to draw VT diagram. What is there in the problem that suggests you to draw VT diagram? That you should know. And it's simple. Read problem very carefully. A car starts with no initial velocity and accelerates uniformly along a straight path. And when its velocity reaches 108 kilometers per hour, the driver applies the brakes so that the car decelerates uniformly to a stop. So it is only one particle, the car, but its acceleration is different in different time intervals. That suggested me to draw VT diagram. Is it not possible to solve this problem using x is equal to ut plus half at squared and v is equal to u plus at, etc.? Yes, but motion curves approach will give you quick answers, and that is why we should use motion curves approach if acceleration is different in different time intervals. And if in each time interval it is a constant, directly draw VT diagram. Particle starts with no initial velocity, so at t equal to 0, v0. So here you should start drawing the curve. Uniform acceleration means it is inclined straight line. What is velocity reached by the particle? 108 kilometers per hour. Kilometers converted into meters and divided by 3600. So it is 30 meters per second. So insert that value. If you know a value, you should insert it. Up to what time it is accelerated motion, we don't know. So we have labeled it as t dash. What happens at t dash? Driver applies brakes so that the car decelerates. Car decelerates uniformly. So again it is uniform acceleration. When acceleration is constant, VT diagram is inclined line. And acceleration is negative. That means it is downward slope for that inclined line. And it stops. Total time duration is given. Total time duration is 21 seconds. That is why we inserted that. At t equal to 21 seconds, it stops. So this is how we have completed the drawing, VT diagram. So really speaking, I am taking time to explain you certain things, but once you have understood, in no time you will be able to create this diagram. And after drawing VT diagram, nothing to think. Area under VT diagram gives displacement. So what is asked in the problem? Find distance travelled by the car. Okay. Area under VT graph is change in position or displacement. So in any time duration, say for example T1 to T2, you want to know displacement. If you want to know displacement from T1 to T2, just check what is area under graph in that time interval. Now you want to know total distance travelled. Do you remember I have told you in earlier lectures? That is, if distance travelled is asked, you should check whether particle changes its direction of motion. If particle does not change its direction of motion, distance travelled is equal to magnitude of displacement. Now in this case, particle does not change its direction of motion. Just one glance at this diagram is enough to know that. Throughout the motion, velocity is positive. What does that mean? Throughout the motion, particle moves in positive direction only. So no change in direction of motion. So here distance travelled is a displacement. So how to find that displacement? Displacement from 0 to 21 seconds, t equal to 0 to 21, t equal to 21 seconds. Displacement from t equal to 0 to t equal to 21 seconds is equal to area under VT graph from t equal to 0 to t equal to 21 seconds. So this is that area under VT graph. It is simple, triangle, base into height by 2. So displacement is area under VT diagram. So base is 21, height is 30, check here, divided by 2, and that is 315 meters. And we know that since particle does not change its direction of motion, distance travelled is displacement. Next problem. A car starts from rest and accelerates uniformly. So from first statements, what you realize that it is uniform acceleration motion. When its speed reaches 90 km per hour, the driver applies the brakes so that the car decelerates uniformly to a stop. Total duration of the motion is 24 seconds. If distance covered during accelerated motion is twice the distance covered with decelerated motion, then find the acceleration. So here acceleration is different in different time intervals. So that suggested us to draw VT diagram. So let's draw first VT diagram. How to solve this problem? Draw VT diagram and then area under Vt diagram displacement and change in velocity by time, that is acceleration. This is that logic we are going to use to solve this problem. So time along x-axis, velocity along y-axis. Motion starts from rest, means initial velocity is 0. At t equal to 0, velocity is 0. It accelerates uniformly, means velocity increases uniformly. So it is straight inclined line. But velocity is given in kilometers per hour. So you should convert it into meters per second. And it is 25 meters per second. Now draw Vt diagram. Uniform acceleration, velocity is increasing uniformly. And what is maximum velocity reached? Yes, we know it, 25 meters per second. And corresponding time instant, you should label it as t dash. What happens after this? Speed reduces uniformly. And it stops. At what time it stops? 24 seconds. Okay, so I have inserted that value. So this is Vt diagram for the entire motion. After drawing Vt diagram, what? Area under Vt diagram is displacement and change in velocity by time, that is acceleration. These are the two formulae we use to solve uniform acceleration problem using Vt diagram. So distance travelled from t equal to 0 to t equal to 24 seconds is area under Vt graph from t equal to 0 to t equal to 24 seconds. Now check here, when its speed reaches 90 kilometers per hour. This Vt diagram is not velocity time diagram, but it is speed time diagram. What I am telling you, listen. Area under Vt diagram, we say displacement. And area under speed time diagram, it is distance travelled. Distance travelled is area under Vt diagram. So from t equal to 0 to t equal to 24, it is base 24, height 25 by 2. So total distance travelled is 300 meters. So we have found out total distance travelled. But here it is given that if distance covered during accelerated motion is twice the distance covered with decelerated motion. So this area under Vt diagram during accelerated motion is distance covered during accelerated motion. Let it be S dash. And this triangular area, that is distance covered during retarded motion from t dash to 24 seconds decelerated motion, and during this motion distance covered. So total distance travelled is 300 meters. Therefore S dash plus S double dash is equal to 300 meters. And also we have one information in the problem that distance covered during accelerated motion is twice the distance covered during decelerated motion. So S dash is twice S double dash. So this is second equation. So from this equation, S double dash is S dash by 2, put it in equation 1 and you have found out S dash. So S dash is 200 meters, means S double dash is 100 meters, because total distance travelled should be 300 meters. So this is how we have found out distance covered during acceleration, distance covered during retardation. Now distance travelled is equal to area under Vt diagram, but now we have selected distance travelled from 0 to t dash. 0 to t dash, distance covered is S dash, and that is t dash into 25 by 2, base into height by 2, and we have found out it as 200 already. So that gives you value of t dash. So t dash is 16 seconds. In these calculations, what information we have used? Have you realized? Area under Vt diagram displacement or area under speed time diagram is distance travelled. And now we are asked to find acceleration. Now this is important to understand. Acceleration is from 0 to t dash seconds, and from t dash seconds onward it is a retarded motion. So we'll focus on accelerated motion only. So acceleration, what is change in velocity? 25 minus 0, in final velocity is 25, initial velocity is 0. So change in velocity is 25 minus 0, and corresponding duration, it is 0 to t dash. So final time instant minus initial time instant, and t dash we know it is 16. So this is how we have found out acceleration. So to find acceleration, what information we use? Change in velocity by corresponding duration. Read this problem. An automobile starts from rest and accelerates uniformly for 50 seconds to cover 250-meter distance. Then continues to move with the same velocity for 2 minutes. And then further increases its speed uniformly to 25 meters per second with the rate 0.5 meters per second squared. And then the driver applies brakes to reduce its speed uniformly to stop. If total distance travelled is 2.5 kilometers, then find total duration of travel, average speed of the car and its final retardation. Simple problem. You should draw VT diagram. What is there in the problem that suggested you to use VT diagram? Acceleration is different in different time interval. So along x-axis time, along y-axis velocity. It's very easy. Actually, in no time you will be able to draw VT diagram, provided you have really understood it. This is the point where time is 0 and velocity is 0. Automobile starts from rest, that means initial velocity is 0, accelerates uniformly for 50 seconds, means velocity increases uniformly for 50 seconds. So show that inclined straight line, velocity increasing uniformly up to 50 seconds. So this time is 50 seconds. Now what is that velocity reached? We don't know. So label it immediately, V dash. An automobile starts from rest, accelerates uniformly for 50 seconds. That is what we have shown in the diagram, to cover 250-meter distance. In the sense, this area under VT diagram gives displacement. This area is distance travelled, you can directly write 250 meters. Have you understood? This is that information we have drawn here, or we have shown in the graph. This is how. Then continues to move with the same velocity for 2 minutes. So that is what we will show. So 2 minutes means add 120. 2 minutes means 120 seconds. So this time instant is 170. And then further increases its speed uniformly to 25 meters per second. So from this instant t equal to 170, its speed increases uniformly, means inclined straight line again, and its speed reaches 25 meters per second. So this value of velocity is given 25 meters per second. But up to what time this accelerated motion? We don't know. So I have labeled that time. But this acceleration 172 t dash is 0.5 meters per second squared, means slope of this line is 0.5 meters per second squared, that is given. Then the driver applies brakes to reduce its speed uniformly to stop. So speed reduces uniformly and it stops. What is time here? We don't know. So I have labeled it. But there is information in the problem we have not yet utilized. And what is that information? Total distance travelled is 2.5 kilometers and acceleration 0.5 meters per second. This accelerated motion is from 170 seconds to t dash seconds. Distance travelled, that is area under VT graph. So this distance travelled is 250. It's given. I have chosen time interval 0 to 50 seconds. So that area is base into height by 2, 50 into V dash by 2. So we found out velocity 10 meters per second. So put that value immediately in the diagram. That helps you to study diagram quickly. So V dash is 10 meters per second. Now distance travelled from t equal to 50 to t equal to 170. Area under VT graph from t equal to 50 to t equal to 170. So how much is that? This area, base 120, 50 to 170, and height is 10, and it is rectangular area, so base into height. So this area we have found out. Area under VT diagram during uniform velocity motion is 1200 meters. Now 170 to t dash. This is the information. 170 to t dash, it's given that acceleration is 0.5 meters per second squared. So we know that acceleration is change in velocity by duration. So what is change in velocity here? Final velocity is 25 and initial velocity is 10. That is why 25 minus 10, that is change in velocity. And what is that duration? T dash minus 170. Only this time duration you are selecting. Final time minus initial time. So T dash minus 170. So we got T dash as 200. Now let's find distance traveled in this duration, 170 to 200. So distance traveled from t equal to 170 seconds to t equal to 200 seconds. It is combination of a rectangle and a triangle. So rectangular area 30 into 10. Base is 30 and height 10. Height means velocity. It is 10. So 30 into 10. Plus this triangular area, base is 30 and height is 15. Listen, it is 10 to 25 means it is total 15. That is height of this triangular portion. So 30 into 15 by 2. So this is how we have found out distance traveled in these 30 seconds. 525 meters. So this area under VT diagram from 170 seconds to 200 seconds. This is the distance traveled during this accelerated motion and it is 525 meters. And finally, this triangle is distance covered during retarded or decelerated motion. So total distance traveled is given 2500. So distance traveled during initial accelerated motion plus distance traveled during uniform velocity motion plus distance traveled during accelerated motion in these 30 seconds plus this distance traveled, and this is that area. How much is this area? We don't know. So in terms of T double dash, base is T double dash minus 200 into height of this triangle is 25. Height means velocity in this diagram. So base into height by 2 because it is triangular portion. So in this equation there is only one unknown, T double dash. So you will get total duration of travel 242 seconds. So T double dash is 242 seconds. Now distance traveled by corresponding duration. You are asked average speed. Listen, speed is continuously changing. Average speed means total distance traveled divided by total duration. So total distance traveled is 2500 and total duration is 242 seconds. So this is average speed. And final retardation. Retardation is in this portion, that in this duration 200 to 242 seconds. T double dash is 242 seconds. So in this duration retardation is. So it is change in velocity divided by duration. So it is negative acceleration means it is retardation. So when you write retardation, don't say negative sign. Remember, if you write answer as acceleration, then use negative sign. And when you write answer as retardation, then negative sign is not required because negative sign is hidden in this word itself. Retardation means this acceleration is negative. Let's read this problem. Repairing work is in progress on a 2.5 kilometer long railway track. A train running at a speed 108 kilometers per hour reduces its speed uniformly from 108 kilometers per hour to 36 kilometers per hour, covering a distance 500 meter as it approaches the track being repaired, and runs over it at this lowered speed. After covering the track being repaired, the train increases its speed uniformly from 36 kilometers per hour to its full speed 108 kilometers per hour in a distance of 1.8 kilometers. So with the lower speed, train covers this 2.5 kilometer long railway track where repairing is in progress. But after covering this track, train increases its speed from 36 kilometers per hour to 108 kilometers per hour. and to increase its speed from 36 to 108 kilometers per hour, it covers 1.8 kilometers. Now find the time lost by the train due to the repairing work in progress. Listen, very mechanically you can solve the problem if your concepts are clear. When you read this problem, before you end reading of this problem, you have taken decision of drawing VT diagram. Because here the train increases its speed uniformly, decreases its speed uniformly, or certain distance it covers with uniform lowered speed, that suggested you that draw VT diagram. If motion of a particle is different in different time interval, if acceleration of a particle is different in different time interval, and in each interval it remains constant, then draw VT diagram. And after drawing VT diagram, area under VT diagram displacement, and change in velocity by time, that is acceleration. This is how we solve the problem. In VT diagram, when that V is speed, then area under VT diagram is distance traveled, directly distance traveled. Okay, so check here. First we'll draw VT diagram. Along x-axis time, along y-axis velocity. The train is already moving with velocity 108 kilometers per hour. That 108 kilometers per hour is 30 meters per second. And then it reduces its speed 36 kilometers per hour, that is 10 meters per second. So train reduces its speed uniformly to 10 meters per second. That is why this inclined line is. So up to what time this reduction in speed is, that time we don't know. This area under VT diagram is given. How much distance it covers? 500 meter distance it covers in this decelerated motion. After that, train moves with the lower speed. Up to what time it moves with the lower speed, we don't know that. Lower speed means 10 meters per second. But how much distance it covers, we know it. Because it moves this with this speed 10 meters per second on this railway track where repairing is in progress. That means 2500 meters. After that, train increases its speed to its full speed, that is 30 meters per second. Up to what time it is accelerated motion, we don't know. So I have labeled it as T triple dash. So this is how VT diagram is complete. But area under VT diagram is displacement. In this case, area under speed time diagram is distance traveled, and that is given. So we are going to use that information. Check. During its decelerated motion, train covers a distance 500 meters. Then with uniform velocity 10 meters per second, train covers this distance 2.5 kilometer. So train moves with its lowered speed on the track where repairing is in progress, that is 2500 meters. So with the lower speed, train covers 2500 meters. And after that, train increases its speed. The train increases its speed uniformly from 36 kilometers per hour to full speed 108 kilometers per hour in a distance of 1.8 kilometers. That is, this area is 1800 meter. Okay, so we are using this information. Consider duration 0 to T dash, that is this duration. Area under VT diagram, how much is that? Rectangle plus triangle, so T dash into 20 by 2, that is this triangular portion. Height of the triangular portion is from 10 to 30, means 20. Base of this triangle is T dash, so T dash into 20 by 2 plus lower rectangular portion T dash into 10, and that is given as 500. So you have found out T dash. Next, T dash is 25, insert that value immediately in the diagram. Now next area is 2500 meters. So T double dash minus T dash, or T double dash minus 25 into 10, base into height, that is 2500, and you have found out T double dash because here T dash is 25. Insert this value of T double dash here in the diagram, and write this area. It is again rectangle plus triangle. So consider duration T double dash to T triple dash. And what is the area? Watch here. It is rectangle plus triangle. So base is T triple dash minus T double dash. That value of T double dash is 275. That is base. So base of the triangular portion is T triple dash minus T double dash into height is 20 divided by 2 plus this rectangular portion T triple dash minus T double dash, that is this length, and height is 10. It is rectangle. So base into height, and that area is distance traveled by the train during accelerated motion, and it is 1800. So T triple dash is equal to 365 seconds. So total time taken by the train to cover this much distance, how much is that distance? 500 plus 2500 plus 1800. This entire distance, total time taken is 365 seconds. What is total distance covered now? 500 plus 2500 plus 1800 is equal to 4800 meters. And total time taken is 365 seconds. To cover the same distance, that is 4800 meters, with the full speed of the train 30 meters per second, how much time is required? 30 meters per second. Simple mathematics. 30 meters per second. So to cover 4800 meters, how much time is required? 4800 divided by 30, that is 160 seconds. To its full speed, the train would have covered this distance in 160 seconds. But actually, due to this repairing work, train took 365 seconds. So how much is the time wasted by the train? 365 minus 160. So time lost by the train is 205 seconds. So in this lecture, what you studied, listen, and that's most important thing. If acceleration is different in different time interval, but in each time interval it is uniform, then draw VT diagram, and after drawing VT diagram, area under VT diagram is displacement and change in velocity by time is acceleration. Now when the VT diagram is speed time diagram, then remember area under that speed time diagram is distance traveled. Now read all those solved problems I have given you to understand it better. Thank you.